So today we're going to focus on sine and cosine together, because you guys have already experienced tangent ratio. These are considered the three primary trig ratios. Okay. Sine, like you guys have noticed on your calculator, is some equation. You use your calculator to solve, and we refer to the angle. So we're going to refer to the same angle every time so you can see the difference between them. It'll be the angle at the top here. This will be our unknown angle. We'll call it theta. Okay? Unknown angle. Sine is equal to the opposite. Well, the opposite side is the side that does not touch the angle, so this is considered the opposite. Okay? Opposite divided by the hypotenuse. What part of the triangle is the hypotenuse?
The long side.
Yes, the side that'll be opposite of our right angle, which I supposedly should have drawn in. Now, it's important to notice that you can only use these primary trig ratios when we have right angle. Oops. When we have right angle triangles. Okay? So this is the hypotenuse. In our cosine, the adjacent side is the side touching the triangle. It's the side touching the triangle that's not the hypotenuse. And then obviously the hypotenuse has not changed. So cosine theta, that angle, is equal to the adjacent side divided by the hypotenuse. And finally, just to go over it one last time so that you guys know, tangent is opposite, and we'll just kind of put that in short form, over adjacent, which you guys have already experienced this already. Now, it can be tough to remember these. So there is a mnemonic device they use, and what they say is Sohcahtoa. Sohcahtoa. And the reason they go about saying this is to remember what each of the ratios is equal to. So in this case, sine, S-O-H, is equal to the opposite over the hypotenuse. Okay. Ka is cosine, is equal to the adjacent side over the hypotenuse. And toa is equal to the opposite divided by the adjacent side. Okay? So they're all referring to these, but instead they're just using an acronym to represent it. Okay? So if you get confused, you're not sure, just try to remember this mnemonic device, Sohcahtoa. Okay? S-O, and it's always the hypotenuse, C-A, hypotenuse, and then toa does not use the hypotenuse. Okay? So in setting these up, we have to remember it's always in reference to what angle. If I was at the angle down here, then the opposite side would have been over here, but the hypotenuse stayed the same. If our angle was down here, the adjacent side would now be down here, but our hypotenuse would be the same. And if we're talking about this angle here, this would become the opposite, and this would become the adjacent. Okay? So it changes every single time. We must make sure we know what angle we're referring to in order to use these primary trig ratios. Okay, so we've created a triangle down here. We're going to go about solving. And we're going to use sine and cosine to solve for this angle here. So because this is our unknown angle, which side is considered the opposite? 10. Right? So 10 is opposite, which makes what the adjacent? Good. This is our adjacent. And therefore, by deduction, the last one is what? Hypotenuse. That's what I was looking for. Good. The hypotenuse. Good. So, according to this angle, sine theta, is equal to what? What does the O stand for? Opposite. So that's 10 in this case, divided by what's the hypotenuse? 26. Easy. Okay. We're going to go about solving that in a second. I do want to set up our cosine right beside it. Cosine theta is equal to what? Adjacent, which is 24, divided by 26. So, notice that we're actually solving for the exact same angle. Okay, we're solving for the exact same angle in this question, but our ratios are different depending on whether we're using sine or cosine. We're going to see if we end up with the same answer when we go through this. So, we have the ratio. I need to isolate the angle. Isolating the angle, what am I going to move to the other side, hypothetically?
Sin.
Yeah, and then what does it become on the other side?
-1.
That's right, the inverse. Good. So, theta in this case is equal to the inverse, so sine inverse of 10 over 26. That's supposed to be a power of negative 1. I'm going to fix that. Okay? And then the same idea, theta is equal to cosine inverse. Again, it's not like me. Cosine inverse of 24 divided by 26. So we're going to put those in our calculators and figure out what theta is equal to and how close these two ratios end up becoming. Oops, not theta. Okay, so in this case, 10 divided by 26 is equal to, and then I have to push inverse. I think it's this one here. No, wrong button. Sorry, that's long. I'll do that one more time. 10 divided by 26. There, that's inverse. Now we have sine inverse. I hate this calculator. So some of your calculators may work like this, where you have to actually input everything one step at a time. 10 divided by 26 is 0.384. Inverse sine, 22.6. Okay, 22.6 degrees. That's what we got when we did the sine. And we made sure we were in degrees. Let's retry this again. 24 divided 26 is equal to the inverse of cosine, 22.6. So, even though we use different sides of the triangle, depending on whether we're using sine or cosine, we ended up with the exact same angle. That's very important that you guys notice this. And if we used tangent, we would have still got the exact same angle. But I know you guys are already pros with tangent. All right, so we've created another triangle down here. Okay, but in this case, we're actually going to solve for sides. Now, we're going to reference the exact same angle. But I want to show you that sine and cosine will actually solve for different sides of a triangle if we're referring to the exact same angle. So, for instance, sine 33, that's the angle here, is equal to what? Okay, because it's opposite, it would be the x over the hypotenuse, which is 10. Or in the other case, cos 33 is equal to what over 10? Why? Because it's looking for the adjacent side over the hypotenuse, okay? So when we set them up using the exact same angle, we're actually going to solve for different sides of the triangle. Now, you guys are used to also doing it when the variable's on the bottom. It's the same idea as tangent, just an extra step. So we're just going to focus on this for now. I need to isolate x in the first case and y in the second case, okay? So in order to do that, we need to move what to the other side? 10. When I move 10 to the other side, what is it going to become? Great. 10 times sine 33 equals x. Does anybody else see that? And 10 times cos 33 equals y. Okay. So in each case, x and y, we're going to plug them into our calculator, see what we get. So, because of my calculator is a little older, I actually have to make sure I do sine first. So I'm going to do 33 sine times 10, 5.4. 5.4 is my x. Okay, and the other case, cos 33 times 10, 8.38. Okay, is our y. So we solve for different parts of the triangle depending on whether we used sine or cos. And the same idea would have been true if we'd used tan, just like you guys are used to using. Okay, so that's kind of a rundown on sine and cosine. That's solving for an angle and solving for a side. Is this